Good morning, you guys. Hope you're having a great day. Here's our day 9 note sheet. There will be homework after, but you can keep replaying this if you need to. Okay, so we're going to be solving radical functions. We need to think about just solving in general again. So just to do a little problem up here off to the side, if I go like 2x plus 3 equals 7, the first step is always add and subtract. So move this piece over, and then you get 2x equals 4. I did the opposite of add, I subtracted. Now I'm going to do the opposite of multiply. I'm going to divide, so I get x equals 2. You have to think of opposite operations. That's what we're trying to do. So up here it says to solve a radical equation, you need to eliminate the radicals or rational exponents. This means you need to raise each side of the equation to the same power. Okay, the power property of equality looks like this. So if a equals b, then a to the n equals b to the n. What that really means is you have to have the same power. Okay, so if we look at this one, I have x to the 1/3. I'm going to rewrite this equals 4. To be able to get rid of that 1/3, I have to do the same thing to both sides. If I raise that to the 3rd power, or think of it back up here, the cube root to the 3rd, those two would cancel each other out, or 1/3 times 3, when I multiply those two together, power to a power, I get x to the 1st. So then I get x to the 1st equals 64. Okay, so to undo a root, you have to exponent. Those are opposite things, okay? You need to check and make sure if you plug this back in that the cube root of 64 does equal 4. You should kind of mentally check that off to the side, because when we start getting more complicated ones like b and c and further down, you could have extraneous roots again. The extraneous, I think that's how you spell it. Extraneous roots means extra. Oops. And I can't spell extra. I'm not restarting this video, so you're going to keep watching. Means extra. Okay, make sure that you solve for those, because you could have answers that look nice but don't work. So check those extraneous roots. Check for roots that don't work. Okay. So if I put 64 in there, the cube root of 64 is a positive 4. That's good. So what I mean by an extraneous root that might not work, if this had been the cube root of x equals, say, -4, when I plug that back in and I got 64 equals, when I solve this, -4, the cube root of 64 is 4. 4 doesn't equal -4. So that would be a bad answer. This is an example of something that could happen and give you an extraneous root. That is not the answer to this problem. That's why I did it in a different color. But just so you know, you got to look for that type of thing. Okay? All right. And you only need to do that when it's a root. When you're raising it to an exponent, like a whole number 3, that's the only time you have to check. Okay, so I'm going to subtract 2 from both sides on this one. You always add or subtract first, then you can undo an exponent or a radical if needed. Okay, so 4x minus 7. All of this is under the square root, so I can't move anything else. This stuff is all bound in here in my square root. This is a 2 because it's not written. So to undo that square root, we're going to square it. Or you could think of this as 4x minus 7 raised to the 1/2 equals 3. And to undo that half, I can square it. So I'm going to square both sides. I don't care which path you like or which one you think looks better. Just do the one that looks best for your brain. So when I do that, now I have 4x minus 7 equals 9. Now this is just an algebra problem. Solve that and divide by 4. So you get x equals 4. But you should check that to make sure that it does turn out something nice. So square root of 4 times 4 minus 7. You can use the equal to 3. You don't have to put it in the 2 and then the 5 part. So I get square root of 16 minus 7 is 9. And the square root of 9 does equal 3. So that's a good one. Okay. All right, next one. I'm going to divide by 2. I have to get my variable, whether it's written like a radical or in fractional form as a rational, whatever it is, you have to get the x stuff or the square root by itself before you can take powers. So when I divide this one, I get x to the 3/2 equals 125. Oops, 125. Oops, and I'm still not writing. 125. Okay, now our end goal is to get x to the first power. To get x to the first power on this one, I'm going to have to multiply by the reciprocal, a 2/3, because a power to a power, as long as I do it to both sides, that's legal. And then if I do this, I get x to the 6/6, which really reduces to 1, which was my goal. So now I've got this x equals 125 to the 2/3. And we're going to have to simplify that like we've already been doing. So I have 125 to the 1/3 squared, or you can write it as the cube root if you'd like to see it that way, either one. But these will both come down to a 5 squared, which gets me x equals 25. Since this is divide by 2, the original problem actually is the square root of x squared. We should, cubed, sorry. We should put that in there just to make sure that we're going to get a nice number, but they're both positive, so square roots are equal to positive numbers. So I have 2 square root of 25 cubed. That's going to be some huge positive number, but that's equal to 250. As long as this is positive and this is going to equal a positive number, that's what you're looking for, making sure that it's got the correct sign. The numbers will work itself out. You're just looking to see, does this in fact give me a positive answer? This side is positive. In the long run, that's really what you're checking for, but you could do the math and check that that comes out. Okay? All right. Ooh, this one has lots of square roots. If I tried to square this side, this would lead me into a FOIL, because I would have to take 3x plus 2 minus 2 square root of x times that. When there's add or subtract, you cannot distribute. No distribute with add or subtract. So this route is not going to make this look nicer. We don't want to do that, okay? So instead, what we're going to do, the square root of 3x plus 2, we're going to move that x plus 2 square root of x to the other side. So I added this to both sides because that red version was like a no-go. We don't want to do that if we don't have to. Okay, so I move that over. Now I can square, because remember, when there's nothing there, that's really an index of a 2. I can square both sides fully. I have to square that 2 out in front as well. So now this squared and this square root cancel out, and I have 3x plus 2. Now on this side, I really have 2 and the square root of x squared. Since this is a multiply, I need to use my distributive property on this one. It's not add and subtract, it's multiply. So that gives me a 2 squared times the square root of x squared. So this square and this square cancel out, and 2 squared is 4. So I end up with 4x over here, 3x plus 2. Now I can solve this. It's only x's, so I'm going to subtract 3x from both sides. I know it looks weird, but I want to keep my variables positive. So I get x equals 2. We did a lot of like moving around over there. I should check this. The square root of 3 times 2 plus 2. So that gives me the square root of 6 plus 2. So the square root of 8 minus, I get 2 square root of 2. So 2 square root of 2. Square root of 8 is square root of 4 and 2. So that's 2 square root of 2 minus 2 square root of 2 equals 0. Yep, that does check out. So that's a good answer. Okay. This next one. There is no way to get this square rooted x out from underneath there and have a nice x on this side. The best we can do is square both sides. When you have x's on both sides, one of them square root, or if there's square root on both sides, you're going to have to deal with both sides. So I have to square this. By squaring this, this means x minus 4 times x minus 4. We cannot distribute past an add or a subtract. On this other side, the squared and square root will cancel out, and I'm left with just a 2x. So now I have to FOIL. I get x squared minus 4x. FOIL minus 4x plus 16 equals 2x. X squared minus 8x. We really want to bring this on this side. So minus 2x plus 16 equals 0, because I can't factor unless I get down to a 0 on the other side. So I get x squared minus 10x plus 16 equals 0. Now we're back to unit 1. I hope you don't try to quadratic formula this. I would hope that you can diamond, or you can see the factor that we've done these enough. What multiplies to 16 and adds to negative 10, that would be a negative 2 and a negative 8. So we get x minus 8 and x minus 2 equals 0. Now using the zero product property, we can set each piece, each factor equal to 0. And when I solve that, I get x equals 8, and over here I get x equals 2. I need to check this. This is a lot just happened again, like up above. So I need to plug 8 in there. So I get 8 minus 4 equals the square root of 2 times 8. So 4 equals the square root of 16. Yep, that one's okay. And I get 2 minus 4 equals the square root of 2 times 2. So I get negative 2 equals the square root of 4. That's a no-go, because this answer without a variable in there, I don't get plus or minus. I would have 2 equals 2. That's not true. Sorry. So that answer has to go away. So only the 8 actually worked. Okay? All right. I want you to pause the video, and I want you to try these down here, and then turn it back on and check your work. So pause now, and then turn it back on, and I will show you how to do them. Welcome back, cheaters. I know you didn't pause, but that's okay. Okay, and to those of you who did, I'm so proud of you. All right, so we're gonna divide by 2 on both sides. I get x plus 3 to the 4th equals 16. Now, if I was square rooting this, when you square root both sides with a variable, you need to put plus or minus. That goes with a 4th power as well. If you have an even power and you 4th root, or like square root, if you root both sides, you have to have that plus or minus when a variable is involved. Since that's a 4th, if I 4th root both sides, or if you want to think of that as x plus 3 to the 4th and raise this to the 1/4, it's the exact same thing, just written a little bit different, because 4 to the 1/4, when I multiply those together, I get 1 on that side. That leaves me with an x plus 3, and then the 4th root of 16 is 2. So now I'm back to that quadratic stuff that we did first semester when I have that negative 3. Remember, it scooches in between the negative, or the equal sign, and the plus or minus, and I have to do 2 answers. So x equals negative 3 plus 2, and x equals negative 3 minus 2. So I get x equals negative 1 and x equals negative 5. I need to check those. Oops, different color for checking. There we go. So I'm going to plug it back into the x plus 4 squared equals 16, because dividing by 2 doesn't really harm it. If I put this one in here, negative 1 plus 4 squared, no matter what happens when I'm squaring that, that squared is going to make this a positive answer. So I get 3 squared equals 16. Except for I can't add, oh, because that's supposed to be a 3. So this is 2. And I messed up again. I don't want to redo the whole video. You guys are going to have to be patient with me. Just a second. When I plug this one back in, I get negative 1 plus 3 to the 4th power equals 16. So I get 2 to the 4th power. That's why, because I was talking too fast and I put squared up there. So 16. So I get 2 to the 4th is 16. So that one worked. And then over here, I get negative 5 plus 3 to the 4th power equals 16. So I get negative 2 to the 4th power. Negative 2 times negative 2 times negative 2 times negative 2 does give me, in fact, 16 and 16. So that worked. So those both work. Sorry about my little flaw there. Okay, so this next one, I need to get the x stuff by itself. So I'm going to add 4 to both sides. And I get the cube root of x equals 3. So this is really like saying x to the 1/3. So to undo that, I would have to multiply by 3, or cube root and cubed are opposites. So whichever path you want to write it, whichever way, I don't care. So then we get x equals 3 cubed is 27. The cube root of 3 to the 3rd is x, and 3 cubed is 27. And we should just plug that in just to make sure. The cube root of 27 minus 4 equals -1. I get 3 minus 4 equals -1. So I do, in fact, get -1 equals -1. That's a good answer. Okay? I know I went kind of fast. Sorry, I made a mistake over here. It's a good now. Please watch through. Please practice and do your homework now. And we will check these on Monday. Have a great weekend.